My name is Richard Iverson. I'm a research hydrologist at the U.S. Geological Survey Cascades Volcano Observatory here in Vancouver, Washington. My work focuses particularly on the dynamics of debris flows, debris avalanches, and other kinds of mass movements that occur at volcanoes and also can occur in other settings as well. Debris flows are basically masses of rock and mud and water that travel rapidly down slopes and downstream under the action of gravity. Volcanoes are a particularly ripe setting for large debris flows and debris flow disasters, in part because there are these huge steep piles of rubble and there's nearly an infinite supply of loose debris sitting there that can possibly get involved in one of these flows. It's important to realize that the hazard around volcanoes like those we have in the Northwest goes well beyond the immediate environs of the volcano. It extends well downstream in lowlands areas, perhaps as much as 100 kilometers away from the volcano, as a result of these long travel debris flows. The goal of the research group that I lead is quantitative forecasting of hazards from debris avalanches and debris flows. That work involves several components. There's a field component that entails simply observing and measuring what happens when these events occur naturally in the field. There's a laboratory experimentation component that involves making artificial debris flows at our USGS Debris Flow Flume. And then there's a mathematical modeling component, part of which involves actually deriving appropriate equations to describe the behavior. And then there's the task of actually solving those equations and portraying predictions on a computer. The experimental component of our work is conducted largely at a facility we call the USGS Debris Flow Flume. This is basically a huge concrete chute built on a steep hillside about 50 miles east of Eugene, Oregon. And what we do with this facility is mix up batches of debris that are very similar to natural debris in debris flows, and then let them flow down the chute from a distance of about 100 meters. And this allows us to make lots of measurements under controlled conditions, and additionally allows us to repeat the experiment over and over to make sure that we're getting replicable results. And without that kind of experimental testing, it would really be difficult to know whether our models are performing as well as we would like them to. Some of our models have been used extensively throughout the world for making long-range hazard forecasts, and also sometimes implemented in sort of an emergency situation as well. And that's really gratifying to see that the science has that kind of practical application. This work really does lead to saving of lives and additionally to protection of property to some degree.